Hello and welcome to your first live lesson for working from home for Nat 5, and we're going to talk about simultaneous equations today. So, simultaneous equations contain equations with two or more letters that must be calculated. So it's easy when we have solve an equation with just one letter, we can just move the numbers to the other side. When there's two letters, it's a different process altogether, it's not that easy. So in National 5 we work with what's called linear equations, which is basically equations of a straight line, as you can see just if I underline these two in example 1. The solution to simultaneous equations is the coordinate where the lines meet. So the solution to these simultaneous equations is the point at where they intersect. Okay, so there are two ways that we can do this. The first way is to do it graphically, which is by actually drawing the lines and then just looking at where they cross over. And you can do it algebraically. The graphic method we're going to do first, which is really just to show you kind of how this all works and what our aim goal is here, is to find the coordinates where they meet. But going forward we will be using this algebraic method most often. Okay, so we're going to do example 1, which is the graphic method, which involves drawing the lines on a set of axes. So if you haven't already, can you draw a set of axes like this? If you don't have squared paper, it's okay, just estimate the kind of numbers on each axis. So find graphically by drawing the point of intersection of the lines y equals x minus 2, y equals minus x plus 6. So in order to draw these lines, there's two things we need to know. We need to know the gradient and we need to know the y-intercept. Okay, so that's what we're going to have to find for each of these first. So we'll draw each of these separately, y equals x minus 2 and y equals minus x plus 6. Now in order to draw them we need to know what m is and we need to know what c is in our equation. So as you can see in the first one, it's a 1x, so m has a gradient of 1, which means you go along one box and up one box. The y-intercept is of course whatever number is on the end of the equation, which in this case is minus 2. So that means it will cut at the point 0, minus 2. In the second, which I'll actually do in a different colour just to make life easier, do that one in red, y equals minus x plus 6. So what was my gradient? Well, this time the gradient is at negative 1, which means every time I go along one I go down 1. And c, the y-intercept this time, is of course 6. So it's cutting at the point 0, 6. So I can then go to my axis now and plot on some points and draw these lines. So start with the blue one first, y equals x minus 2. Now the first thing you're going to do is mark on the y-intercept. That's your starting point. Now this is a y-intercept of 0, minus 2, which means if I go onto my axis it's going to cut through at 0, minus 2. So that's minus 2 there. Gradient of 1 means every time I go along one box I go up one box. So that would be my next point there. Then I would go along another box and up another box. That's what a gradient of 1 means, along one, up one. So you can keep on doing that a few times, along one, up one, along one, up one. And then you should be able to then draw a nice straight line, joining them. You can extend it on a bit. The red line now, which is minus x plus 6. Now we start with our y-intercept, which is 0, 6, so count up 6 boxes, 1, 2, 3, 4, 5, 6. Gradient of minus 1 this time means that every time we go along one box we go down one box. So we're going to continue on that pattern and you will see obviously these two are going to then meet. So I can get another line, draw it through these points here and you can hopefully quite clearly see that these points meet at this intersection right here. So what is that coordinate? We just literally read off the boxes, counting boxes. That's all we have to do. So we would say the POI, which is the point of intersection, POI, point of intersection, is whatever the coordinate is from the graph. So 1, 2, 3, 4 along, and 1, 2 up. So my point of intersection is the point 4, 2.